Right, and welcome. Uh, right now I will be proving a cosine rule. So remember our last video where I proved the sine rule. So if you're not related to sine rule, go check that video before you prove cosine rule, because there are some extra information that you really need to understand before you can even prove these things. I say to you, there are three trigonometric goals that we're gonna use in determining the sides of triangles that do not have 90 degrees. So this rule is one of them. So it's called cosine rule. So cosine rule is a little bit challenging when proving, so I want you to pay attention and to take note of everything that I will be doing right now. Now these these are the formulas that you or we are going to use to determine the sides. These formulas are formulas for cosine rule. We're going to use these formulas to determine the sides or to determine the angles of triangle that do not have 90 degrees in it. So again, when proving cosine rule, it's either you're going to prove it using the acute triangle, or you're going to prove cosine rule using the obtuse triangle. So now look, what did I say to you? I said this side, it is small letter c. Why? Because it's opposite to angle C. And this side, it's small letter b, because it's opposite to angle B. This side, it's small letter a, because it's opposite to angle A. Same applies to your obtuse triangle. This side, it's small letter a, since it's opposite to angle A. This side is small letter b, since it's opposite to angle B. And this side, it's small letter c, since it's opposite to angle C. Okay, that's very important to take note of. Now with cosine rule, they say you are required to prove that b squared is equals to a squared plus c squared minus 2ac multiplied by cos angle B. Now guys, this is what I want you again to take note of. So you are required to prove b squared. Look, the angle and the side you are required to prove supposed to correspond. So this is b squared, meaning we're talking about angle B. Like here we have a squared, meaning we're talking about angle A. We have b squared, we're talking about angle B. We have c squared, we're talking about angle C. So that means here we're talking b angle B. That means your B, it's supposed to be at the origin all the time. If you were required to prove that c squared is equals to blah 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 cos angle C, your C, it was supposed to be here at the origin. Do you understand what I'm saying? So that means for this proof, B, meaning our B, it has to be at the origin. Okay, all right. Now before we prove, definitely we're going to construct respectively. So we're gonna join A to produce maybe T, and we're gonna name this length H, which is height. And here we're gonna construct, in this triangle, we're gonna construct this A, we're gonna join A to also produce T, and we're gonna call this height H, which is this length H, which is the height of a triangle. Now remember, your height is parallel to your y-axis. That means your height will act perpendicular to your x-axis. Same applies here. Your height is parallel to your y-axis. That means your height, it is going to act perpendicular to your x-axis. Okay, now that's our construction. We're gonna join A to produce T in a form of height by forming a height. Okay, all right, now let's go through a proof. Now guys, before we prove this, okay, this is what I want you to take note of. You have to know the coordinates of point A as well the coordinates of point C. You have to know the coordinates of point A and the coordinates of point C. So now I'm going to use this triangle. You can also use this triangle, guys. These two things are the same. The approach or everything that I'm going to write here is for both triangles. Do you understand what I'm saying? So I'm going to use this one. Now in order for us to prove this rule, we have to know the coordinates of these points, point A and point B. So coordinate system is given by x is to y. We know that coordinate system is given by x is to y. So mean we're going to determine the coordinates of A. Now, so how are we going to determine the coordinates of A? Check, guys. From here, from B to T, B it is at the origin, T it is at a certain point, meaning from B to T we are talking about the x value of T. We are also talking about the x value of A, because AT it is a straight line and then it is also parallel to y-axis, meaning the x value of T corresponds with the x value of A. But now how are we going to determine that coordinate? We're going to use this triangle ABT. So remember, we're going to use trig functions because it has 90 degrees in it. So we're going to say to determine x, we're going to use adjacent over hypotenuse. And remember, your hypotenuse is C. Adjacent over hypotenuse meaning we're going to use cos. Cos adjacent over hypotenuse, meaning the x value of A, it is going to be C cos angle B. Meaning the x value is C cos angle B. Can you see that? And therefore, let's determine the y value of A. The y value of A is height, is h. But how are we going to determine that? It's opposite over hypotenuse. That means the y value of A, which is h, is C sine angle B. And the coordinates of C, it's, remember from here to here, it's x value, which is A, meaning our x here is A and y, it's 0. Okay? Alright, now let's prove. You can also do the same thing on this triangle. It's still the same, okay, but I'm choosing to work with this triangle. So now with our proof, remember we are asked to prove that b squared is equals to a squared plus c squared minus 2ac cos angle b, meaning we are proving b squared. So this is length b, ac is length b. So you're gonna use distance formula. You're gonna say ac squared is equals to distance formula x of a minus x of c to the power of 2 plus y of a minus y of c to the power of 2. Why am I using distance formula? Because I want b squared, or then b squared is equals to how much? Can you see that? So that means what is the magnitude of AC? AC is b to the power of 2 is equals to what is x of a? X of a is c cos angle b. And then what is x of c? X of c is a to the power of 2 plus what is y of a? Y of a is c sine angle b. And what is y of c? It's 0. Okay, and therefore let's work it out. Remember here we have b to the power of 2, which is equals to, let's expand this. So by expanding this, we're gonna say c cos angle b to the power of 2, it's c squared cos squared angle b, and we're gonna say c cos angle b multiplied by negative a multiplied by 2 is negative 2ac cos angle b, and then we're gonna say negative a to the power of 2 is positive a squared. And therefore remember, don't forget we have squared there, this minus this, c sine angle b minus 0, it's c sine angle b to the power of 2. It's gonna be c squared sine squared angle b, and therefore we have b squared here is equals to, look, I'm going to group this with that. Okay, I'm going to group this with that. So this one here, we have a squared, which is this one, plus c squared cos squared angle b, group this one, c squared sine squared angle b, minus this one, 2ac cos angle b. So guys, what I did here, it's a rearrangement. I rearrange what I've determined on top. Okay, so I have b squared is equals to a squared. I am going to take out the common factor, so my common factor here is c squared, and I left with cos squared angle b plus sine squared angle b minus 2ac cos angle b. and therefore have b squared is equals to a squared plus sine squared. Remember, this is a square identity. Cos squared b cos squared angle b plus sine squared angle b is equals to 1 minus 2ac cos angle b, and therefore b squared is equals to a squared, c squared multiplied by 1, it's c squared minus 2ac cos angle b, and therefore this is what you were basically required to prove. Oh my god, I'm not sure if you saw that. Therefore this is what you're required to prove. It's a cosine rule.